Back to week 3 for junior cycle ordinary level. So today we're going to be going through 2 topics. So the first is equations and the second one is factorizing. So we've touched on this briefly in the previous lessons, but we're going to be going into it in more detail today. So I'm going to put up a couple of examples. So we'll deal with equations first. So we're going to be dealing with linear equations. Now, linear equations, what you're going to be looking out for in those, you're going to be looking out for an equal sign. Okay, so we're going to be looking at a couple of examples here now. So the first example is going to be solve. So solve the following linear equation. And the linear equation in this case is going to be x plus 3 is equal to 8. So you have to solve for x. When it says solve, it means you want to get a value for x. I'm just going to write that up here. So solve for x. You want to get a value for x. So x plus 3 equals 8. This is our equation. Now you remember from a previous lesson, when we're looking at linear equations, we need to isolate the variable. So the variable is x. That we don't know what x is. So we need to isolate that on its own. So we need to get this on one side. And whatever we're doing to isolate x, we must do the same on this side. Okay, so we want to get x on its own. How do I get x on its own? Well, you have a plus 3 here. You need to make it a 0. So how would we get rid of 3? We'd take away 3, wouldn't we? So it's going to be x plus 3 minus 3 is equal to, and remember we must do on the right hand side what we do on the left hand side, so it's going to be 8 minus 3. 3 take away 3 is 0, so you're going to be left with x is equal to 8 minus 3 is 5. So the second example is going to be 3x plus 12 is equal to 21. Now again, you need to solve for x. So in this case, we want to isolate 3x first. So we need to get rid of 12. We need to make it 0. So how would we get rid of 12? Well, you have 12, take away 12 will give you 0. So it's going to be 3x plus 12, take away 12 is equal to, and remember on the other side we need to do the same, so it's going to be 21, take away 12. Because you're taking away 12 on this side to get rid of the 12, so you need to do the same on this side. So 12 minus 12 is 0, so you're going to get 3x is equal to, so 21, take away 12, it's going to give you 9. Now we want what x is, not what 3x is, so we need to get rid of the 3. So 3x means 3 multiplied by x. So in order to get rid of the 3 here, we would have to divide by 3. So it's going to be 3x divided by 3 is equal to, remember we're doing the same on the right hand side, so 9 divided by 3. So 3x divided by 3, you're left with x. And 9 divided by 3 is 3. So you've solved for x. Okay, we're going to look at another example now. So this one is going to be 3x minus 3 is equal to 21. So the same idea here, we want to isolate the variable. So the variable here is 3x, we want to get x on its own. Now, in order to do that, we want to get this on its own, so we need to get rid of the 3. So it's minus 3. So if we added 3, we'd get rid of it. So if we add 3 on this side, we need to add 3 on this side. So it's going to be 3x minus 3 plus 3 is equal to 21 plus 3, because we're doing the same to both sides. So they cancel, and you're left with 3x is equal to, so 21 plus 3 is 24. And we need to get rid of the 3 that's attached to the x here. So if we got rid of the 3, we'd have to divide it by 3. So 3x divided by 3. So 3x divided by 3 is equal to 24 divided by 3. 3x over 3 is cancel. It's going to be x is equal to 24 divided by 3, which is 8. So we're going to give another couple of examples now. So example 4. So it's going to be 6x plus 1 is equal to 4x plus 7. Now this is a little bit different because we have our variables on both sides of the equation. So the idea here is to get the x's on one side of the equation and then the numbers on the other. So usually the variables go on this side, so the x's would go on the left hand side, and then on the right hand side you'd put your constants, which is your numbers. So if we look at this side first, so we want to get rid of the 1. So you have 1 there, you want to get rid of it, so you take away 1. So I'm going to take away 1 from this side and take away 1 from this side. So it's going to be 6x plus 1, take away 1, equals 4x plus 7, take away 1. Okay, so they cancel because 1 minus 1 is 0, so you're left with 6x is equal to 4x. Now 7 take away 1 is 6. So now we need to get x's, all of the x's over to this side. So we're going to have x's on this side and numbers on this side. So we want to get 4x, we want to get rid of 4x there. So how would we get rid of 4x? We'd take away 4x. So if we're taking away 4x from this side, we're going to take it away from this side. So it's going to be 6x minus 4x is equal to 4x minus 4x plus 6. 6x take away 4x is going to give you 2x equals, so 4x take 4x is 0, and you're going to be left with 6. So 2x is equal to 6. So the way we get rid of 2 here is divided by 2. So it's going to be 2x over 2 is equal to, and remember we need to do the same to the right hand side, so 6 divided by 2. 2 divided by 2 is 1, so you're left with x is equal to 6 divided by 2 is 3. Now I know these are a little bit trickier, so we're going to do a couple more examples of those. So put example 5. So example 5 is going to be 3x plus 25 is equal to 7x minus 3. Now, the same idea here. We want to get x on this side and numbers on this side. So we'll look at this first. How do I get rid of the 25? So you have plus 25 there. So if you took 25 from 25, you get 0. So we're going to take away 25 from this side. So if we're taking 25 from this side, we're going to take it away from this side. So we're going to rewrite the equation. So it's going to be 3x plus 25 minus 25 is equal to 7x minus 3. We're going to take 25 from that side as well. So it's going to be 3x. So 25 take 25 is 0. So we're left with equals 7x. And you have minus 3 minus 25. That's going to be minus 28. Okay, so the idea then, we need to get rid of the x on this side because we need to keep the numbers here. So how do I get rid of 7x? So I have plus 7x. I take away 7x to get 0. So if I take away 7x on this side, I'm going to take 3x, take away 7x, is equal to 7x minus 28. 3x minus 7x is going to give you minus 4x, and that's equal to 7x take away 7x is 0, and it's going to give you minus 28. Now I want to get x on its own, so I need to get rid of the minus 4. The way I get rid of the minus 4 is I divide by minus 4. And remember, I'm doing the same to this side as what I do on this side. So it's going to be minus 4x divided by minus 4 is equal to minus 28 divided by minus 4. So they cancel, and you're left with x is equal to. Now 28 divided by 4 is 7. Now you have two minuses, so minus 28 divided by minus 4 is going to give you 7, because minus divided by minus always gives you plus. So the answer there is x is equal to 7. I'm going to do 2 more examples of those linear equations on the next slide because I know they can be a little bit tricky. Okay, so the next example there is going to be 6a minus 4 is equal to 5a minus 8. Now again, same idea here, we want to get a's on this side and numbers on this side. So let's look at this part first. I want the letters on this side, so keep 6a. So I need to get rid of 4. So I have a minus 4. How do I get rid of the minus 4? I need to make it 0, so minus 4 plus 4. So we're going to add 4 to this side, and we're going to add 4 to this side. So it's going to be 6a minus 4 plus 4 is equal to 5a minus 8 plus 4. So it's going to be 6a, and then minus 4 plus 4 gives you 0, so that's equal to 5a, and then minus 8 plus 4 is minus 4. Okay, so now we have a on this side and we have the number on this side, but we need to get rid of the 5a. So that's a plus 5a. We assume it's positive if there's no sign in front of it. So how do I get rid of 5a? I take away 5a. So I'm going to take away 5a from this side, and I'm going to take away 5a from this side. So it's going to be 6a minus 5a is equal to 5a minus 5a minus 4. 6a minus 5a is 1a. 5a take 5a is 0, so it's going to be equal to minus 4. So the answer there is a is equal to minus 4. Okay, we'll do one more of those examples. So example 7 this time. So this one is going to be 2x plus 15 is equal to 5x minus 3. And again, we want to get the x's to this side and numbers to this side. So let's look at this part first. I want to keep 2x. So plus 15, I need to get rid of that. So how do I make that 0? So 15, take away 15 will give me 0. So I'm going to take away 15 from this side, and I'm going to take away 15 from this side. So it's going to be 2x plus 15 minus 15 is equal to 5x minus 3 minus 15. That's going to be 2x, so 15 take 15 is 0, is equal to, so 5x, now minus 3 minus 15 is going to give me minus 18. Okay, so again, we want to keep x to this side and numbers to this side, so we need to get rid of that 5x. So the way we get rid of that 5x, it's a plus 5x, so we'd take away 5x to get 0. So I'm going to take away 5x on this side and take away 5x on this side. So it's now going to become 2x minus 5x is equal to 5x minus 5x minus 18. 2x take away 5x is minus 3x. 5x take 5x is 0, so you're left with minus 18. Now, I want to isolate x on its own, so minus 3x. How do we get rid of the minus 3? We divide it by minus 3. So we're dividing by minus 3 on this side, and we're dividing by minus 3 on this side. So now it's going to be minus 3x over minus 3 is equal to minus 18 over minus 3. So they cancel, and you're left with x is equal to minus 18 divided by minus 3 is going to give us 6, because minus divided by minus is plus. Okay, so we're still on equations, but we're going to be looking at solving problems, or solving word problems using linear equations now. So we're on to example 8, and this is going to be very word-based, but we're going to use the same format to solve them. Okay, so the question is, let x be a number. So let x be a number. The number is doubled. And 7 is then added. Okay, so what you need to do for this is to write an expression in terms of x of the resulting number. Now the next part of that question, when the number is doubled, so when the number is doubled, and 7 is added, the result is 39. Sorry, 29 that should be. Part B is to write an expression or write an equation. So write an equation to show this. And the final part of the question is to use this equation to solve x. Okay, so use this equation to find x. Okay, so there's a lot of words there. Let's look at the first part. So let x be a number. That number is doubled and 7 is added. So the first part is to write an expression in terms of x of the resulting number. So x is a number, x is doubled. So there you have x. If we double x, it's going to be 2 times x. And then it says that 7 is added. So it's going to be 2x plus 7. That's your expression. Write an expression in terms of x of the resulting number. So let x be a number. So I wrote down x first. Then it says the number is doubled, so that's going to be 2 times x. And then it says that 7 is added, so you're going to add 7. So that's the answer to part A. For part B, when the number is doubled and 7 is added, the result is 29. So they're saying that this is equal to 29, and that's the answer to part B. Write an equation to show this. So for part B, what you have from part A, so 2x plus 7, the result is 29. And then for part C, use this equation to find x. So we want to get x on its own. So I'm going to just do this up here. So you need to solve it. So 2x plus 7 is equal to 29. So this is what we've been doing leading up to this. So remember, we want to get x on this side and then numbers over here. So I need to get rid of the 7 here because I want to get 2x on its own. So if I have 7 there, how do I make that 0? So 7 take away 7 is 0. So I'm going to take away 7 from this side. And don't forget, if I take away 7 from this side, I need to take away 7 from this side. So it's going to be 2x plus 7 minus 7 is equal to 29 minus 7. So next line is going to be 2x, they cancel because 7 minus 7 is 0, is equal to, so 29 minus 7 is going to give you 22. Now here we want to get x on its own, so we need to get rid of the 2. So the way we get rid of the 2 is divided by 2. So if we're dividing by 2 on this side, we need to divide by 2 on this side. So it's going to be 2x over 2 equals 22 over 2. 2 divided by 2 is 1, so you're left with x is equal to 22 divided by 2 is 11. And that's the answer, so x is equal to 11. Okay, so we're going to do a revision of factorising. I know we did this in one of the previous lessons, but just to recap. So you've got 4 kind of factorising types of equations. The first one we're going to be looking at is the highest common factor, which is HCF. So we're going to give an example here. So with HCF, you're going to be asked to factorise 2x plus 2. Okay, and this is by finding the HCF, which is the highest common factor. Now, the way we do this, I'm going to write it out. So 2x plus 2. So let's have a look and see, is there anything that's common to 2x and 2? So x is only common to this term, but we have 2 that's common to both terms. So what we're going to do is we're going to pull out 2 and open up our brackets. What multiplied by 2 gives me 2x? So if I put x in here, I'd get 2x. So x is going to be there. So 2 by x gives me 2x. We know that's right. Now what multiplied by 2 gives me 2? So 2 multiplied by what gives me 2? And the answer is 1. So 1 is going to go here. So that's so again, the way I did that was take out what's common. So you're taking out what's common to both terms, and 2 is common. So I pulled out 2. 2 by x gives me 2x, and 2 by 1 gives me 2. So that'll work out. Okay, so the next example under highest common factor. The question is to factorise 3ab plus 6ab by finding the HCF, which is the highest common factor. So I'm going to write that out again. So we have 3ab plus 6ab. Now, let's look at the number first here. Is there any number that goes into both 3 and 6? The answer is 3. 3 goes into both 3 and 6. Now, we also have an a common to both, so we're going to pull that out. And we also have a b that's common to both, so we're going to pull that out as well. So now, what multiplied by 3ab gives me 3ab? So the answer is 1. So 1's going to go here. And what multiplied by 3ab gives me 6ab? So the answer is going to be 2. 2 goes there. So just test it. So 3ab by 1 gives me 3ab plus 3ab by 2 gives me 6ab. And if you were to add them together, you would get 9ab. So the next one is factorising by grouping. And again, we touched on this and we'll just go back over it. So factorising by grouping. Okay, so in that case, we're going to give you an example. So example 1. So you are going to be asked to factorise AC plus BC plus 3A plus 3B. Now with these, you might remember, you need to pick two pairs. We're going to group these together and group these together. And the reason I'm grouping those together is because you have something common here. You have a C here and you have a C here. So I'm going to group those together. You have a 3 here and a 3 here, so I'm going to group those together. So I'm going to rewrite it. So it's going to be AC plus BC plus 3A plus 3B. And remember, we're grouping them and we're grouping them. So we're going to pull out what's common for both sets. So C is common here. So I'm going to pull out C. Now, C multiplied by what gives me AC? It's going to be A. So A goes in there. C multiplied by what gives me BC? So it's going to be B that goes in there. Plus. Pull out what's common here. It's going to be the number 3. So that's the only thing that's common. So I'm going to pull out number 3. What multiplied by 3 gives me 3A? So it's going to be A that goes in there. What multiplied by 3 gives me 3B? So it's going to be B that goes in there. Now you will notice at this point that you have the same letters in this set of brackets as you do in this. And that's good. You must have the same in each set of brackets. Each of the sets of brackets, sorry. So what we're going to do now, the final step, is you're going to open up two sets of brackets and you're going to put C plus 3 in one set, so C plus 3, and then A plus B in the other, and that's it done. So I'm going to do another example of that just to clarify. So example 2, and again you're going to be asked to factorise. So you're going to be asked to factorise, this time it's going to be AK plus BK plus 4A plus 4B. Okay, so we're going to pick which ones we're going to group together. So we'll group these two because they both have K, and we'll group these because they both have 4. So it's going to be AK plus BK plus 4A plus 4B. Okay, so we're grouping these together first. So what's common to both of those? It's the letter K. What multiplied by K gives me AK? It's going to be A that goes in there. What multiplied by K gives me BK? It's going to be B that goes in there. Now if we look at the second pair, so what's common to both of those? It's the number 4. What multiplied by 4 gives me 4A? It's going to be A that goes there. What multiplied by 4 gives me 4B? It's going to be B that goes there. And again, you will notice that you have the same letters in this set of brackets as you do here, which means that you're right. So you're going to open up your brackets again, and it's going to be K plus 4 in the first set, and A plus B in the second. Okay, so the next thing we're on to is the difference of two squares, which we've met before, so we're just going to do a quick recap. So you will be asked to factorise. It won't say use the difference of two squares, it will say factorise, so you have to be able to recognise that. So the first question is to factorise x squared minus 9. Now, you will see that that's something squared minus, now can we rewrite 9 as something squared? We can write it as 3 squared. So we're going to write that as x squared minus 3 squared. Now the rule is, when you have something squared, take away something squared, you open up two sets of brackets, you're going to put x in the first, x in the second, 3 in the first, 3 in the second, because it's x squared, so one of the x's will go here, one of the x's will go here, and this is 3 squared, so one of the 3's will go here, the other 3 will go here. And the rule is plus with one, minus with the other, and that's it. Okay, so we're going to do another example there of that, so example 2, and it's going to be factorise y squared minus 49. Now again here it's something squared, so y squared take away, we can write 49 as 7 squared, so we're going to rewrite it. So it's going to be y squared take away 7 squared. So now we can open up our brackets. We're going to put y in the first, y in the second, 7 in the first, 7 in the second, plus with 1, minus with the other, and that's it. So we're on to the last section now of factorising. Okay, so we're on to quadratic trinomials now, so I'm going to run through an example here, and we have covered this already, so it's just going to be revision, and then I'm going to complete an exam question with you. So again, you'll be asked to factorise, and the example I'm going to give you this time is going to be x squared minus 3x plus 2. So what we do, we're going to look here. So you have an x squared term, you have an x term, and you have a number, which is a constant. So we're going to circle the constant, which is 2, and we're going to write out the factors of 2. So it's 2 by 1, so there's no other factors of 2. So we look at the middle number. The middle number is minus 3, because we look at the sign in front of it. So we need these two numbers either add or subtract to give us the middle number, which is minus 3. So we have a 2 and we have a 1. So we need to decide what signs are going to go in front of the 2 and the 1. So if we put a minus 2, minus 1, that will give us a minus 3. So we're going to open up our brackets, and because it's x squared, we're going to put x here and x here. Okay, so we're going to put x here and x here. Then we look back at our numbers. We have a minus 2 and a minus 1. So we're going to put minus 2 in one bracket and minus 1 in the other. And that's how you solve that, the quadratic trinomial. So I'm going to do an exam question now based on what I'm after going through with you, and it should be a lot more clearer. Okay, so we're going to do an exam question now. So if we look at this question, the letter J stands for Jake's age in years. You're told that the letter J stands for Jake's age in years. Fill in the table by writing an algebraic term in terms of J to match each description. 2 have already been filled in for you. So Jake's age now is J. Jake's age in 2 years' time is going to be J plus 2, because it's plus 2 years added on to what his age is now, which is J. Jake's age in 5 years' time. Well, Jake's age now is J, and in 5 years' time, he's going to be 5 years older, it's going to be plus 5. Jake's age 4 years ago. Well, Jake's age now is J. 4 years ago is minus 4. Twice Jake's age. Well, Jake's age now is J. So twice Jake's age is going to be 2 times J, which is 2J. And finally, 1/3 of Jake's age. So Jake's age now is J. So 1/3 of Jake's age would be J divided by 3. So that's pretty straightforward. I'm going to do the second part of that question on the next slide. Okay, so you're asked to solve the equation. So 5m plus 2, I'm just going to write this out, 5m plus 2 is equal to 2m plus 35. Okay, so for that, remember we're going to try and get the variable on one side, number on the other. So the m I'm going to keep over here. So if I want to keep 5m there, I need to get rid of the 2. So the way I get rid of the 2, so it's plus 2 there, if I take away 2, it'll get rid of it. So I'm going to take away 2 on the left-hand side. It's going to be 5m plus 2 minus 2 is equal to 2m plus 35, and we need to take away minus 2. So it's minus 2 on that side as well. So we're going to be left with 5m, so 2 take away 2 is 0, is equal to 2m, 35 take away 2 is 33, plus 33. Now, one more step here. We want m on this side and numbers only on this side. So we want to get rid of the 2m. So that's a plus 2m at the minute. So if we take away 2m, it'll make 0. So we're going to take away 2m on this side, which means we have to take away 2m on this side. So it's going to be 5m take away 2m is equal to 2m take away 2m plus 33. 5m take away 2m is 3m is equal to, so 2m take away 2m is 0, you're left with 33. Now this bit here, we need to get rid of the 3. So the way we get rid of the 3 is divide by 3. So if we're dividing by 3 on this side, we divide by 3 on this side. So it's going to be 3m over 3 is equal to 33 over 3. 3 divided by 3 is 1, you're left with m is equal to 33 divided by 3 is 11. So that's it for this week, guys. I would take the midterm, so take the opportunity at midterm to go back over the first 3 weeks of the revision countdown, and we'll be moving on then after we come back after midterm break. And I'm going to put a couple of links as well in the chat for you to refer back to, so some extra questions and extra notes you can access on the website. Have a lovely midterm, and I will speak to you after it.